In today's workshop, we will review linear regression and go over how they can be solved both by hand and using your NCES approved calculator. Solving by hand, we will use a streamlined 4-step process along with the formulas that we are given in the NCES reference handbook. When solving with our calculator, we will use the built-in linear regression functionality of the CASIO FX-115ES Plus. In its most basic form, the topic of linear regression falls under the subject of engineering probability and statistics. Equations, symbols, tables, and information on the various topics covered under engineering probability and statistics can be referenced on pages 36 through 52 of the NCES Applied Reference Handbook, version 9.3 for computer-based testing. Let's start off by defining what exactly linear regression is. Linear regression is the method of drawing a straight line through a set of data points. This line helps us relate a cause and effect relationship within the data that is presented, where the independent variable is the cause and the dependent variable is the effect. Using the method of least squares regression, with defined data points, we are able to predict a number of things, including the value of a dependent value y based on the value of an independent variable x. Today's workshop is going to be rich in data, but when it's all said and done, we are going to dramatically decrease the stress and strain that these types of problems put on our mind and the time with a few clicks of a button on your calculator. So what are the prerequisites for linear regression? Simple linear regression is appropriate when the following conditions are satisfied. The dependent variable y has a linear relationship to the independent variable x. We can quickly determine if this is the case by viewing what the scatter plot of the data looks like. If it's linear, it will look something similar to this. If it's not linear, then you would see something more like what you're seeing right there on the right. However, going into the exam, I'm confident you're not going to have to make a call on whether or not a set of data points represent a linear pattern. The problem statement will likely define it for you. Now, the second prerequisite is that for each value of x, the probability distribution of y has the same standard deviation. When this condition is satisfied, the variability of the residuals will be relatively constant across all the x values, which is easily checked in a residual plot. It will look something like this right here. A residual plot is a graph that shows the residuals on the vertical axis if the points in a residual plot are randomly dispersed around the horizontal axis. A linear regression model is appropriate for that data. Otherwise, a nonlinear model is more appropriate. Again, chances are that you aren't going to have to determine if these prerequisites exist on the exam. However, I wanted to make sure that you were exposed to them because any one of these definitions could be a simple word problem on the exam. So file these definitions away so that you're able to recall them if necessary. So what is the least squares regression line? Linear regression establishes a straight line called the least squares regression line, or abbreviated as LSRL, that best represents observations in a bivariate data set. Suppose y is a dependent value and x is an independent variable. The population regression line is then y is equal to a hat plus b hat x, where a hat is a constant and the y-intercept, and b hat is the regression coefficient and the slope. X is the value of the independent variable, and Y is the value for the dependent variable. This formula can be referenced in its basic form on page 39 of the NCES Applied Reference Handbook. Again, that's version 9.3. So how do you define a regression line? In the real world, we would use a computational tool such as Excel or a graphing calculator to find the characteristics of a regression line. However, we know that we aren't able to bring anything other than a simple calculator into the exam. So we must first solve these types of problems from a conceptual, manual perspective. The regression line is given in the standard form of y is equal to a plus bx and can be defined using a four-step process. Here are the steps and the equations. Step 1 is to define the various metrics that are related to the data given. I, like many of you probably, use a table to complete all of these calculations in an organized way. I will illustrate how I do this when we go through a practice problem. For step 2, we calculate the slope of the line, also known as the regression coefficient, which is given by that b hat equation right there, where n is the sample size, sxx is the sum of the squares of x, sxy is the sum of the xy products. And these formulas right here can be also referenced on page 39 of the NCES Reference Handbook, version 9.3. Step 3 is to determine the y-intercept by plugging in the mean of our x values, the mean of our y values, and the regression coefficient we just calculated. The equation is right there on your screen. And finally, we need to determine the goodness of fit by calculating the coefficient or the correlation coefficient, which is R. These formulas as well can be referenced on page 39 of the NCES Applied Reference Handbook. Note that we call this the goodness of fit, which is probably how the majority of us were taught to call it while in college. The reference manual refers to it as a sample correlation coefficient, so don't mistake it to be anything different. We just want to see how well the data given to us fits the line we have created from it. Typically, if R exceeds 0.85, the fit is good. Otherwise, the fit is poor. If R is equal to 1, then the fit is a perfect straight line. There are a few more formulas that are given to us on page 39 of the NCES Applied Reference Handbook, those being the coefficient of determination and the standard error. We will go over those in another workshop. Solving manually is a fine route to take. It works. Though even the most simple linear regression problems, as you can see, can take a ton of time to carry out and solve. As we can see from these steps, it takes a number of different calculations, meshing and matching various metrics to get to a final solution that we are working for. And let's cross our fingers that we don't make any errors during the process. And this complicates things for a number of reasons. First, our time per problem is limited come exam day. We know this. It's a fact. And second, there are going to be much more complex problems on the exam that will require us to really dedicate more time into solving. We can't waste time on ones that we know we can hack using our calculators. So the lesson, as always, is be smart. Be smart with your time, be smart with the resources you're given, and hack the linear regression problems on the exam using that CASIO. I'll show you just how. When it comes to taking the exam, we have two options when we reach these types of problems. We can either A, solve them using the method of least squares, This is a manual process. It's done by hand. It's acceptable. In my opinion, it works. But it's costly when it comes to carrying it out and opens us up to possible calculation errors. Or we can use our CASIO FX-115ES Plus, deploying the built-in linear regression functionality and the information that's given to us straight in the problem statement. We will run through both of these methods, first by hand and then using our CASIO FX-115ES Plus during this workshop. So let's run through an example. Say we're given the following data points. Let's determine the least squares regression line. The least squares regression line is given in the standard form and can be found using the following process. The first step is to define the various metrics that are related to the data that we're given. Now, I mentioned earlier that I use a table to complete all of these calculations in an organized manner. This is what the expanded table would look like. Our original data is right there in the first and the third columns. And then we just build out the rest from there. Our next step is to take these new metrics and start defining various characteristics of our line. So let's start with the regression coefficient, or the slope of the line. So remember, the general formula is the sum of the xy products divided by the sum of squares of x. These values can be found using the standard formulas presented to us in the NCEES reference handbook. And you can see them right there calculated out. I'm saving you a bunch of time. Combining them all together, we get a regression coefficient of 1.06. Our next step is to determine the y-intercept by plugging in the mean of our x values, the mean of our y values, and the regression coefficient we just calculated. Now, doing this, we get the equation of 3.52 minus 1.06 times 3.48, or a value of negative 0.17. Therefore, the least squares regression line is given by the equation y is equal to 1.06x minus 0.17. But we've got to take this one more step and see if this equation is even a legitimate representation of our data. So let's determine the goodness of fit by calculating the correlation coefficient, R, which is given by the equation right there on your screen. Now, we've defined all the metrics except for the sum of squares of y, SYY, which is given by the formula right there, and that can be found in your NCEES reference handbook. Plugging in all of our values, we get a goodness of fit of 0.999. So our goodness of fit exceeds 0.85, meaning the fit is good, and it's actually nearly a perfect straight line. This means that the equation we have derived to represent the data can be reliably used to predict across other inputs. So now that we know how to manually solve linear regression problems using the standard process and formulas given to us straight in the reference handbook, let's see how we can get it done using our calculator. When using our calculators, we will use the built-in functionality of the CASIO FX-115ES Plus. Let's start with solving the exact problem we just worked through manually. What I will do is run through each step of the process, and then I will flip to a video where I will solve the exact problem live so you can see how it all plays out. So the first step is to activate the data table so we can store the data we are given in the problem statement. To do this, first hit the Mode button to come to a menu that looks similar to this. Once on this screen, press 3 to select option 3 for statistics, and we will be brought to a menu that looks similar to this. Here you will press 2 to select option 2 for a plus bx. We now want to input all the data points. This is where you will fill in all the data points you're given within the problem statement. The x column is where all the x values will be input. The y column is where all the y values will be input. So start with the first x data point, which is 1.2, and input that into your calculator and press the equals button. This will take you to the next data line for the x column, where you will input the remaining x data points as we just did and press the equals button. Once all the data points are input into the x column, hit the right button to switch over to the y column. And because you are on the 6th data line, you will need to press the down scroll arrow once. You will now be on the first row of the y column, which represents the y data points correlated with those x values we just put into our calculator. Input all of these values just as you did for all the x values, and once you're complete, hit that AC button. We can now define the variables of the regression line. With all of our data points input into the calculator, it will now do all the dirty work for us. To do this, click the Shift button and then the 1 button to activate the stat distribution functionality, which is indicated right there in yellow. You'll be brought to a menu that looks similar to this right here. Press 5 to select option 5 for regression. You will be now brought to a menu that looks similar to this, and with all of our data stored within our calculator, it is here that we can get a number of metrics for it. We are also able to solve for a certain independent or dependent value based on that data. The first variable we must define for our regression line is A. So press 1 to select option 1 for A. We will be brought back to the home screen with A displayed. Press the equals button to get our value, which is negative 0.143. We now need to determine the variable B. To do this, click the Shift button and then the 1 button again to activate that stat distribution functionality. You'll be brought back to this same menu as we saw before, but this time we'll still press 5 for option 5, regression. We will now see our regression menu. This time we'll actually press 2 to select option B, or option 2 for B. We'll be brought back to the home screen with B displayed. Press the equals button to get our value, which is 1.051. Adding all this together, we get a regression line which is equal to 1.05x minus 0.14. And this confirms the equation that we previously calculated by hand. In the same regression menu in our calculator, we can get the goodness of fit, which is R, by selecting the option in the same way we did for A and B, which is 0.99, telling us the line fit is good and actually nearly a perfect straight line, which we already knew. So let's go ahead and flip over to a video and see how this problem all plays out live. All right, so that's it. So before we move into a few more practice problems, I want to put into perspective the amount of time that you will be saving when it comes to using your calculator on these types of problems on the exam. Now, if you had to take a guess, how much faster was it to use your calculator versus doing this problem by hand? How many minutes or seconds, or how much did we actually save using our calculator? Hop on over to that GoToWebinar questions box. Just put in your guesses. Was it 20 seconds faster? Was it a minute faster, 2 minutes faster? Put those guesses. Great. Perfect. All right, this is where you're going to be blown away. The first time that I did this problem manually, it took me 7 minutes and 24 seconds to complete. And that's not including calculating that goodness of fit. Now, I have to admit, I did make a calculation error and had to recheck my inputs, but that's the risk that we take when we're doing these problems by hand. And believe me, people are still doing it on the exam by hand. You're not falling into that trap. All in all, 7 minutes is not really what we're looking for. We don't want errors, and we want to get below that magic 3 minute per problem threshold. So check this out. When I did this problem for the first time using my calculator, it took me 28.76 seconds. It took me 29 seconds. That's almost 7 times faster, or 15.3 times faster than doing it manually. Now, if you've taken the exam before, which many of you have, I guarantee one of your experiences was the fact that you ran out of time at the end of your exam, forcing you to guess on a lot of the problems. Knowing how to use your calculator and where you can use it, you will be banking time that others around you are just failing to do. This is going to give you a huge leg up on the competition and a huge leg up on actually getting all the questions answered in the time that you're allotted. All right, so let's run through a few more practice problems to make sure that we got this whole workflow dialed in. In an experiment to determine the relationship between frequency and the inductive reactance of an electrical circuit, the following results were obtained. So we have a table here of data points. Let's determine the equation of the least squares regression line of inductance reactance on frequency, assuming a linear relationship. So our first step is to activate those data tables so we can store the data we are given in this problem statement. To do this, first hit that mode button to come to a screen that looks similar to this. Once on this screen, press 3 to select option 3 for statistics, and we will be brought to a screen that looks similar to this one right here. And here you will press 2 to select option 2 for A plus BX. We now want to input our data points, and this is where you will fill in all your data points you're given within this problem. So the X column is where all the X values will be input. The Y column is where all the Y values will be input. So start with your first data point, which is 50, and input that into your calculator and press the equals button. This will take you to the next data line in the X column, where you will input the remaining X data points, as we just did, and press the equals button. Once all the data points are input into the X column, hit that right button to switch over to the Y column. And because you're on the 7th data line, you will need to press the down scroll arrow once. You will now be on the first row of the Y column, which represents the Y data points, again correlated with those X data points. Input all of these values just as you did with the X values, and once you're complete, hit the AC button. We can now define the variables of the regression line. With all of our data points input into the calculator, let's let it do the dirty work. To do this, click the Shift button and then the 1 button to activate the stat distribution functionality, which is indicated in yellow. You'll be brought to a screen that looks similar to this one. Press 5 to select option 5 for regression. You'll be brought to a menu that looks similar to this, and with all of our data stored within our calculator, it is here that we can get a number of metrics for it. We are also able to solve for certain independent or dependent value based on that data. Now, the first variable we must define for our regression line is A. So press 1 to select option 1 for A. We'll be brought back to the home screen with A displayed. Press the equals button and we are going to get a value of 5. We now need to determine the variable B. To do this, click the Shift button and the 1 button to activate the stat distribution functionality. Once again, we'll be brought back to that same menu we saw before. Here we'll select option 5 for regression. We'll be brought to this menu that you see right here on your screen. Now we're going to press 2 for option 2, which is B. We'll be brought back to our home screen. With B displayed, we can press the equals button to get our value, which is 0.586, which makes the equation of our regression line y is equal to 0.59x plus 5. Remember, in that same regression menu in our calculator, we can get that goodness of fit R by selecting the option in the same way we did for A and B. In this case, we get a value of 0.994, telling us that our fit is good and, again, nearly a perfect straight line. So let's go ahead and flip over to a video and watch how this problem all plays out. And there you go again, saving you a ton of time. So let's go ahead and run through one last example. This problem says a quality control engineer notes a relationship between the amount of chemical added to a batch and the final concentration for the chemical in the final product. If 4 grams is added into a mix, what would the final concentration be? Assume a linear relationship. Now, this is a classic problem the NCEES will throw at you with a lot of noise to distract you. This problem is telling us to assume a linear relationship, but it's not asking us to determine what the relationship looks like in terms of a regression line. There's no indication that we need to be doing that. Instead, it's giving us a value of a chemical being added and asking us to determine what the concentration would be. Remember, the linear regression line helps us relate a cause and effect relationship within the data that is presented to us, where the independent variable is the cause and the dependent variable is the effect. In this problem, the amount of chemical added is the independent variable, and the concentration is the dependent variable. This problem will also show you why I like to use the two variable statistics option in our calculators. Doing so will make this a super simple and quick problem to carry out. Where on the other hand, if we did it by hand, well, you already saw how long it took me to do one of the more simple problems. But if you decided to go forward on the exam on this type of problem, well, you might as well plan on running out of time sooner than you expect to. So let's hack it and let's run through the steps. The first step is to activate the data table so we can store the data we are given in this problem statement. To do this, first hit the mode button to come to a screen that looks similar to this. Again, here you're going to select option 3 for statistics, and we'll be brought to a menu that looks similar to this. Here you will press 2 to select option 2 for A plus BX. We now want to input all of our data points. This is where you will fill in all your data points as we did in the previous problem. Same deal. So let's start off with our first X data point, which is 2. Input that into your calculator and press the equals button. This will take you to the next data line for the X column, where you will input the remaining X data points as we just did and press the equals button. Once all your data points are input into the X column, hit that right button to switch over to the Y column. And because you're on the 7th data line, you will need to press the down scroll arrow once, and that will take you all the way up to the first row of the Y column. Input all of the values just as we did with the X values, and once you're complete, hit the AC button. We can now define the variables of our regression line. With all of our data points input into our calculator, again, we're just going to let it do our dirty work. We're going to let it save us a ton of time. So to do this, click the Shift button and the 1 button to activate the stat distribution functionality, which is indicated in yellow. You'll be brought to a menu that looks similar to this. Press 5 for regression, and you'll be brought to a menu again that looks something like this. Again, all of our data is stored in our calculator, and it's here that we can get all of our variables, all our metrics that we need to solve this problem correctly. We are also able to solve for a certain independent or dependent value based on that data. I know I've said that in all of the other problems, but this is actually a problem where we will use that functionality. So the first variable we must define in our regression line is A. So press 1 to select option 1 for A. We'll be brought back to our home screen as we have before. Press the equals button and we're going to get a value of 1.216. We now need to determine the variable B. To do this, let's click that Shift button and that 1 button again to activate the stat distribution functionality. We'll be brought back to the same menu as we were before. Here we're going to press 5 for regression. We'll be back to our list of metrics that we can get. This time we'll hit option 2 or the button 2 to select option 2 for B. And back on our home screen, we just have to press that equal button to get our value of 0.853, which makes our regression line, the equation for our regression line, equal to 0.85 plus 1.22. Now let's go one more step to determine what the concentration will be if we add 4 grams of the chemical. But before we carry out this operation, we have to know the way that our calculator, the CASIO, likes to carry out these types of operations. Looking forward, What we are going to essentially be doing is inputting an independent variable x, which is 4 in this case, and asking for a corresponding dependent variable of y, or concentration, based off the data and the regression information we have stored within our calculator. To carry out this calculation or this operation, we must first put in our independent value x, and then activate the regression functionality that will determine the associated concentration. This is an important step because if we don't input the x value first, then the calculation will display a syntax error. Now, don't stress, there really is no harm in doing this. We would just have to reverse the input and calculate again. But we are looking for time savings. So understanding the conceptual workflow of our calculator to avoid these issues is going to be key. So recall that we are looking for the concentration of the mixture if we put 4 grams of the chemical. So enter 4 on your home screen. Now we can activate the regression menu in the same way we had previously by pressing the Shift button and the 1 button. And we'll be back to this menu that we're very familiar with by this point. Press 5 for regression. And now we are back on this menu, and knowing that we are looking for a dependent value based off an independent value of 4, we can initiate the calculation by pressing 5 to select option 5 for y hat. This will bring us back to the home screen where you will now see 4 y hat displayed. So essentially this calculation is saying based on the data that you input into your calculator, if we had an independent x value of 4, then what would our dependent y value be? So now all we have to do is press the equals button, and we are given the value of 4.626. So the concentration of the liquid will be 4.63, and that's it. So let's go ahead and flip over to a video and check it out. Check this problem out live. And there you go. So as you see in the problem, when I did it on the video, we didn't have to find the variables of A and B. I just did that so that we can get some more practice finding that linear regression line. But once you put all your data points in, the calculator's already done all the dirty work, so you can go ahead and pull any of the metrics that you want at that point. You can pull the goodness of fit. You can pull anything. So just remember that. So that's it for linear regression. I hope you're taking something away from today's workshop and seeing just how much of an impact that this can make both on your studies and on the exam. Now, can you imagine cutting off up to almost 7 minutes each time you encounter a linear regression problem on the exam? That time is going to get banked along with all the other calculator hacks that we've covered in the past workshops that we will be covering in future workshops. And you add those all together and you definitely won't be the one walking out of your exam saying, I ran out of time. For now, I want to invite everyone back over to the Prepineer forums where we will be posting a replay of this workshop as well as creating a discussion where we will be answering any questions that you have. for linear regressions. So for today, let's wrap it up. Have a beautiful weekend, everyone. May God bless you and your family, and we'll be seeing you in the discussion.